Don't say that on my thing, you know.
Okay, is everyone ready?
Yes.
Andrea?
Professor Altamar, you look really young through my iPad.
That's good. I feel really old on the other side of it. Okay, so now, that's good because I feel real old.
Wait, I'm on the wrong side.
Record time right now.
Oh my God. I can't stand her. Okay, now, here we go. Are you ready, Rose? Hurry up. Come on.
Oh, wait,
Now, here we
on the
go.
wrong
Now,
side.
now this is an eye. Now, you know that the opening that the eye sits in is called the orbit, right?
Right.
Okay, so now in the orbit, you're going to have all these structures that you have to look at. Now, what happens is first we have the muscles. There's 6 muscles that move the eye. And they are controlled by 3 cranial nerves, which you answered on the test, right? 3, 4, and 6. Now, most of them are 3. There's 2 that are not. Okay, so now let's do the 6 muscles and then we'll do the nerves. Okay, this is a straight muscle, straight muscle, straight muscle. Straight muscles are called rectus. This is straight. So this is the superior rectus. This is the lateral rectus.
Which one?
This one out here.
Okay.
And the one over here inside is called the medial rectus. The inferior rectus is underneath. You can't really see it. You have to look deeply. Okay? Now, those are 4 muscles. And then there's 2 muscles, 2 left. Those are called obliques. They spin the eye. There's a superior oblique, which is right here. Okay? And an inferior oblique, which is under here. Okay? Those muscles spin the eye around. Okay? These muscles lift up, push down, pull out, pull sideways. Okay? Now, they're attached to this white stuff, which is called the choroid. Okay? Now, the choroid is continuous in the front with the clear part, which is called the cornea. Okay, now. Then you have the optic nerve back here, which is going back, and it's going to make the right and left optic nerve are going to meet at the optic chiasm, and they're going to cross. And when they cross, they go back to the thalamus. Okay, and I'll show you where it connects to the thalamus later. Now, these 6 muscles have 3 nerves going to them, 3 cranial nerves. Okay, oculomotor is 4 of them. So how you remember it is 2 are special. So you have the superior oblique, right? It goes through a pulley. The Latin word for pulley is trochlea. That's where cranial nerve 4 gets its name from. Okay? So you remember SO4, cranial nerve 4 moves superior oblique. Okay, now, the other one is lateral rectus, this guy. Okay? Lateral rectus, it abducts the eye. Moves the eye away from the midline. Does abduction. So that means it's cranial nerve 6, abducen. See it? Now, everyone else is cranial nerve 3, oculomotor. That's how you remember it. Okay? Now, I always remember the little chemical formula, SO4, LR6, and everyone else is 3. That's the easy way to remember to do it. And then you need to know how to do this because you have the cardinal fields of gaze. Look up, look down, look sideways, laterally, and medial, right? Down at the ground, up at the ceiling. And you tested all the cranial nerves and all the muscles. Okay, now the next thing is the actual parts of the eye itself. So we move this guy out of the way, and we lift this off. Now, this is the cornea. I've said this is the sclera. This is the cornea, right? Underneath the cornea, the sclera, is the next layer of the muscular coat of the eye itself, and that is called the choroid. Okay? And then if you open that up again and look on the inside edge is called the retina. So there's 3 layers, the sclera, the choroid, and the retina. Now, in the posterior side, in the back of the eye, is specialized layers right here, okay, that have the photoreceptors, the rods and cones that collect the light and transmit it to the optic nerve. We'll look at that on a better model, which is bigger, and you can see more. Like that one will show more, okay? But that's the introduction for that. Now this is the optic nerve, cranial nerve 2. Okay, now also on the inside edge, you look in here, there's these layers of muscles, okay? These are called pupillary muscles, okay? They are part of a larger structure, which is referred to as the apparatus, okay? The pupillary apparatus, okay? So this is the muscles. There's two layers. There's radial muscles and circular muscles, okay? They attach to the lens, which is right here, okay? So it goes like this, okay? So they attach to the lens.
Where's radial?
Radial is going out. Radial, like a radius, straight out.
Okay.
And circular is circular on the inside edge. The circular muscles in structures, in general, always seem to be on the inside. And the longitudinal muscles always seem to be on the outside for some reason. I don't know why. But that same thing in the stomach, other structures too. But that's the way it is in the eye as well. So you have the circular and the radial. And these pupillary muscles, they control the position of the lens. Okay? They hold it so it can make it bend more or bend less. Okay? They also control the opening. The opening is called the pupil. Okay? The hole that the light passes through. So you can make it bigger or smaller. If you want to make it bigger, you pull on the radial muscles. If you want to make it smaller, you pull on the circular muscles. Because circular muscles go like this, right? Radial muscles pull back.
Okay? So you put light in somebody's eye.
Right, you flash light in somebody's eye, and it constricts. Those muscles contracting, those pupillary muscles, the circular layer. Okay? Right, okay. And that's how you know if someone had brain injury or not, right? Okay, now. Okay, because that's what the midbrain is doing, right? Remember, the midbrain is very important in visual motor and visual activity, right? Okay? Oh, I forgot the lens. Okay. So that's what you remember with the midbrain, right? That's what the midbrain does. Real important, because 4 and 6 go there, right? Right. 3 and 4 go there, and 6 is coming from the pons. Now, okay. So that's the parts of this eye model. Now, let's go over here to this one. Now, okay. So here's the the sclera, the choroid, and the retina. Notice the retina is blackened because it's designed to absorb light, right? Okay, so now move this over here. And here's the retina, okay? You can see how all these little photoreceptors, okay? They're all, it's very interesting because it's actually upside down. I'll show you on that model. So the light comes through here, it goes through into the space, goes past the cornea into the space. This space called the anterior chamber. It contains the aqueous humor, fluid. Then you have the lens, right? And here's the pupillary apparatus. And here's the radial muscles. And then here is this space. It's called the posterior chamber, and it's filled with vitreous humor. So it's thick, it's like jelly. Now, the light will come in, get bent by this lens, and hit at this right spot right here. It's focused. It's designed to be focused right on this spot. This spot is called the fovea. No, the blind spot is a nerve. This is the fovea centralis. Okay? The fovea centralis. This is where the retina is the thinnest. Now, why is it important that the retina be thinnest? Because the photoreceptors are actually embedded in the retinal wall, but they're facing in. So if you have connective tissue and blood vessels and all the stuff on top of it, it's hard for the photoreceptors to see the light because they look like this. Move down there. Because they go like this. So this is the photoreceptors here. So this is a chunk of the retina. We took this piece and put it here. Okay? So what happens, we can have it like this. Okay? So now what happens is the light is coming this way. So it's going to go through this layer of tissue to get to the photoreceptors here. Okay? Got it? So that's why at the fovea it's the thinnest, because this layer of connecting neurons, all these interneurons in here that connect it to the optic nerve, are the thinnest. So the light can go in and hit. Okay? So this is the pigment epithelium down here, it's called. It's basically very dark color. it's so dark, right? It's really dark, purplish black, because it absorbs all the light that comes in, right? That's why when you look into an eye, you can't see anything, right? You have the pupil is actually black, right? Because the back wall is black, okay? Because it's absorbing all the light. So what happens is, so the light comes in, and here's the photoreceptors. The so-called rods and cones are very famous, right? The rods are for black and white and shape, and the cones are for color, right? That's why when it's like really dark out, all you can see is in black and white, right? It's called scotopic vision.
Like a dog.
Like a dog, right? That's why they can see so well in the dark, is because they have more rods and cones. They can see color, but not as good as humans do. So that's the the retina and the photoreceptors. Now, so again, the light's going to come through, and it's going to go through the cornea, and it's going to go through the aqueous humor, then to the lens, and the lens is going to focus it through the vitreous humor on the fovea centralis in the back, okay, which is on this model somewhere around here. Okay, now, then you have where the optic nerve forms. So if the optic nerve is forming there, you know you can't have any photoreceptors or they're covered up, right? So that means you're going to have the optic nerve. And so the blind spot is the beginning of the optic nerve, and that's in here. That's the optic nerve right there. So here's the detail of the back wall of the retina. This is if you look at like an ophthalmoscope and you look into an eye, you'll have the fovea centralis, the point of maximal visual acuity, and the blind spot, the beginning of the cranial nerve 2, which is 0 visual acuity. Okay? And then the rest is variable. And then you have all the blood vessels. Okay? So that's the model of the eye. Okay? Again, this is the same thing, going through, and it gets focused on the fovea centralis. Okay? There's a couple of different models.